on lens formula, magnification and then power of a lens. So two problems I have for you here. A convex lens of focal length 10 cm is placed at a distance of 60 cm from a screen. How far from the lens should be placed an object so as to obtain a real image on the screen? Calculate the magnification of the image and its characteristics. So here we are provided with a convex lens, and what is the focal length of the convex lens? Focal length of the convex lens is 10 cm. Because the lens is convex, so focal length must be positive. So here I have taken with the positive sign. Okay. Then so focal length 10 cm. The lens is placed at a distance of 60 cm from a screen distance. This convex lens is placed at a distance of 60 cm from a screen. So from the screen means we have to consider the image distance. Okay. So what is the image distance here? Image distance is 60 cm. And we know that for convex lens, on the other side of the lens only we will get the image. So we should be taken with the positive sign. So I have considered the positive sign. Next, what we have to calculate, how far from the lens should be placed an object. Means where we have to place the object, at what distance the object must be placed so as to obtain a real image on the screen. Calculate the magnification of the image and also its characteristics. You have to state the characteristics of the image. Okay. Now by using lens formula, 1 by v minus 1 by u is equal to 1 by f. Okay. So this implies, what is V? 1 by 60, right? Minus 1 by U will be equal to 1 by 10, right? In accordance with the sign convention I have taken, this is plus 60 and plus 10. So 1 by U will be equal to 1 by 60 minus 1 by 10. That will be equal to how much? It will be equal to 1 minus 6. That will be equal to minus 5 by 60, which will be equal to minus 1 by 12. Right? So 1 by u will be equal to minus 1 by 12. Therefore, u will be equal to minus 12 cm. And we know that for convex lens, the image distance must be taken with the negative sign. Here, even in the answer also you are getting minus 3. This minus 12 centimeter. Okay. So this is the solution for the first question. We have calculated the object distance in this case. Next, calculate the magnification of the image and also its characteristics. To calculate the magnification, what we know about magnification? So for magnification, we must take m is equal to v by u. You can take m is equal to v by u. That is equal to, what is v children? V is 60. What is u? U is 12. So that is equal to 5. Therefore, magnification will be equal to 5. Okay? Magnification will be equal to 5. Now. So, what are the characteristics of the image formed in this case? So, the characteristic is already as given, it is a real image. Then a real image afterwards, it is inverted, right? A real image and it is inverted. Object distance and image distance, if you see, object distance is 12, image distance is 60 centimeter, right? So, what will be the characteristics? It is real characteristics. Where shall I write the characteristics? Okay, here already. So, characteristics will be real inverted. Real and inverted image. Okay, so this will be the solution for this problem. Real inverted and also, see, if you consider the object distance is very less when compared to the image distance. So if the image is formed at a greater distance means it is magnified. fix here. So how we have to solve this formula? Use length formula. Okay, to solve this problem, use length formula, substitute the values with the proper signs, then we will get u, that is object distance, as -1 centimeter. So that is for convex lens only, because in case of convex lens the object distance will be of negative. Okay, magnification I calculated, it comes out to be m is equal to 5 centimeter. So by looking at the magnification, after calculating the object distance and comparing it with the image distance, we can infer that the image is real, inverted and magnified. So this will be the solution for this problem. Okay. Next, second problem we shall take now. An object of height 4 cm is placed at a distance 24 cm in front of a convex lens of focal length 8 cm. So what we have a convex lens of focal length 8 cm, and what is the height of the object? Height of the object I have taken it as O is equal to 4 cm, and object distance is 24 cm. Because it is convex lens, I should consider u with the negative sign. Okay, so I have considered u with the negative sign, right? And the focal length, how much is given? Focal length 8 cm. Since it is convex lens, take focal length with the positive sign only. Now find the position and size of the image and state the characteristics of the image. So to solve this problem, let us take the lens formula again. 1 by v, right, minus 1 by u is equal to 1 by l. Is it not? Okay. Now what we should calculate here? Find the position and size of the image. You have to calculate the position of the image and also size of the image. V and I must be calculated. So now let us take 1 by V will be equal to 1 by F plus 1 by U. Just transpose this one. You will get 1 by V is equal to 1 by F plus 1 by U, that is equal to 1 by 8 plus 8, right, plus 1 by minus 24. 1 by minus 24. Is it not? Okay. So how much you will get? 1 by 8 minus 1 by 24. We will get it as 1 by 8 minus 1 by 24. If you just simplify it, you will get 8. 3 times 3 minus 1 by 24. Right? That will be equal to 2 by 24. It will be equal to 1 by 1. Therefore, what will be equal to? Be equal to 12 centimeter. This is the image distance. So, image distance we are getting with the positive sign since it is a convex lens. Now, next what you have to calculate? You have to calculate the, this is A solution for A question. This is the solution. Find the position and size of the image. Size of the image, by that we know that I by 4 will be equal to V by U, right? This implies I is equal to, I is how much? I we have to calculate. I by, what is O? O will be 4, that will be V is 12, U is 24, right? Okay. So therefore, I will, that is equal to, this implies I will be equal to 4 into 12 by 24. So 1 by 4, 6 times, this is not, 6 1 times 6, 2. I is equal to 2 centimeter. I is equal to 2 centimeter. Is it not? So magnification, if you see here, when compared to the size of the object, the size of the image is very, very less. I how much I am getting? I is equal to 2 centimeter only. Is it not? I is equal to 2 centimeter. Size of the image, it will be inverted only because we are using a convex lens, is it not? So here even if you take u is equal to minus 24, you will get minus 2 centimeter. Minus 2 centimeter means it will be inverted image. Here if you want you can take minus sign also. So here you will get minus 2 centimeter. Minus 2 centimeter means magnification is a negative. Is it not? Magnification is negative means it is a real image and also inverted image. So what will be the characteristics here? Characteristics will be real inverted and diminished. I shall write it here. Real, inverted, diminished. These are the characteristics of this image. Okay. This is the characteristics of the image formed in case of this case. So here to find out the solution for the first question, you have to take the lens formula. You will get the object distance as 12 cm. Then use I by O will be equal to P by Q. This will be equal to I by 4 is equal to 12 by minus 24. You are getting it as minus 2 cm. Minus 2 cm, that is the size of the image. It indicates the image is real, inverted and also diminished when you compare with the size of the object. Okay. So what are the characteristics? The characteristics will be real, inverted and diminished. So this is how you have to solve problems on lens formula and magnification. Continue with the numerical problems on refraction of light through lenses. Next problem. The focal length of a camera lens is 20 cm. So we know that in camera we are using a convex lens. So it is in this problem it is understood that it is a convex lens. So the focal length of the camera is 20 cm of the camera lens. Find how far away from the film must the lens be set in order to photograph an object located at a distance 100 cm from the lens. So here what is given for us, you see, focal length is equal to 20 cm. So you can take it with positive sign only, why? Because it is a convex lens. Then what you have to calculate? How far away from the film must the lens be set? Means image distance must be calculated. Okay. What is the object distance? The object is located at a distance of 100 cm. And because it is a convex lens, image object distance must be taken with the negative sign. So use lens formula 1 by V minus 1 by U is equal to 1 by F. Is it not? This implies. Now what you have to calculate here? V you should calculate. So 1 by V will be equal to 1 by F plus 1 by V. So I shall substitute now. 1 by V will be equal to 1 by F is 20 cm. Now U is minus 1 by 100. What you will get? So it is 125 times. 5 minus 1 will be equal to 4. Is it not? So 4 1 time 4, 25 times is equal to 1 by 25. So 1 by V will be equal to 1 by 25. Therefore, V will be equal to 25 cm and we will take this with the positive sign. So, and what distance the screen must be placed, or the film must be placed at a distance of 25 cm so as to obtain an image. Okay. So this will be the solution for this problem. Next, one more problem. A concave lens has a focal length 15 cm. At what distance should the object from the lens be placed so as to form an image at 10 cm from the lens? Also find magnification of the lens. So here we are provided with a concave lens, and we know that the focal length of a concave lens must be taken with a negative sign. Is negative, so take it with negative sign. Now at what distance should the object from the lens be placed so as to form an image at 10 cm from the lens? So image distance is given as 10 cm, and here object and image will be on the same side of the lens. Even V also you must take it with the negative sign only, and U must be calculated and M must be calculated. So use lens formula 1 by U minus 1 by U is equal to 1 by F. 1 by 10. Right? Now this implies 1 by u will be equal to 1 by v minus 1 by, okay, 1 by u will be equal to 1 by v must be taken with negative sign, 1 by minus 10 minus 1 by minus 15, right? So this will be equal to minus 1 by 10 plus 1 by 15. So if you take the LCM, how much it will be? 30. 10 3 times minus 3, right? Plus 2. Minus 3 plus 2 will be equal to minus 1. So 1 by u will be equal to minus 1 by 30. Therefore, u will be equal to minus 30 centimeter. This will be the object distance in this case. Now, magnification. M is equal to V by u is equal to, what is V here? V is 10, right? U is 30, that will be equal to 0.33. This will be the magnification. Remember, magnification is just a number because it is the ratio of similar quantities. This will be the magnification. So, we know that in case of concave lens, we get highly diminished images. Is it not? When compared to the object, the magnifier, the image will be almost 1/3 of the object only. The image will be 1/3 of the object. Okay. These two problems you have to pop it out. So next problem. A converging lens has a focal length 40 cm. Calculate its power. So we have studied about the concept of power also. Power is nothing but what? It is a measure of the deviation of the light when it undergoes refraction through a lens. So how it is deviated, whether the deviation is towards the center of the lens or away from the center of the lens, depending on that we will decide the power of the lens. So here he has given a converging lens has a focal length 40 cm. Converging lens means convex lens it is. So focal length of convex lens is the positive. So it must be taken with positive sign. We have to calculate the power. We know that P is equal to 1 by F in meter. But here the focal length is given in centimeter. Therefore, P will be equal to 1 by 40 centimeter. 1 by 40 centimeter. That will be equal to 100 by 40, right? 100 by 40 if you take it in meters. So, how much you will get? 10 by 4 will be equal to 2.5. P is equal to 2.5 and it is a convex lens or a converging lens, and we know that the power of a converging lens is positive. For convex lens it is positive and whatever units it is direct light. P is equal to plus 2.5 direct plus. Okay. So this will be the solution. One more similar problem I have. The focal length of a concave lens is 10 cm. Calculate its power. So focal length of a concave lens is 10 cm. We know that for concave lens we have to take with the negative sign. Power must be calculated. P is equal to, again 1 by F in meters it is. If you take it in centimeter, it will be equal to 100 by 10. Is it not? And for concave lens, the focal length is negative. So it will be equal to how much? Minus 10. Therefore, P is equal to minus 10. What will be the units? Diameter. This will be the solution. So very simple problems you will have on power of a lens. Okay children, we shall now discuss some of the applications of lenses. So where we are using lenses in our everyday life. Lenses are used as objective lens of a telescope, camera, slide projector, etc. So in all these optical instruments we are using what type of lens? Convex lens, because the convex lens will give you real and inverted images. Okay. So even in a telescope, a camera or a slide projector. Next, even our eye lens is also a convex lens. So there are two convex lens in each one in one of the eyes. Each one in one of the eyes. Hello children, we shall continue with the numerical problems on the refraction of light through lenses. Next problem, the focal length of a camera lens is 20 centimeter. So we know that in camera we are using a convex lens. So it is in this problem it is understood that it is a convex lens. So the focal length of the camera is 20 centimeter of the camera lens. Find how far away from the film must the lens be set in order to photograph an object located at a distance 100 centimeter from the lens. So here what is given for us, you see, focal length is equal to 20 centimeter. So you can take it with positive sign only, why? Because it is a convex lens. Then what you have to calculate, how far away from the film must the lens be set, means image distance must be calculated. Okay. What is the object distance? The object is located at a distance of 100 centimeter. And because it is a convex lens, image object distance must be taken with the negative sign. So use lens formula, 1 by v minus 1 by u is equal to 1 by f. Is it not? This implies. Now what you have to calculate here? V we should calculate. So 1 by v will be equal to 1 by f plus 1 by v. So I shall substitute now. 1 by v will be equal to 1 by f is 20 centimeter. Now u is minus 1 by 100. What will we get? So it is 100 25 times. 5 minus 1 will be equal to 4. Is it not? So 4 1 time 4, 25 times is equal to 1 by 25. So 1 by v will be equal to 1 by 25. Therefore, v will be equal to 25 centimeter, and we will take this with the positive sign. So, and what distance the screen must be placed, or the film must be placed at a distance of 25 centimeters, so as to obtain an image. Okay. So this will be the solution for this problem. Next, one more problem. A concave lens has a focal length 15 centimeter. At what distance should the object from the lens be placed so as to form an image at 10 centimeter from the lens? Also find magnification of the lens. So here we are provided with a concave lens, and we know that the focal length of a concave lens must be taken with the negative sign. Is negative, so take it with negative sign. Now at what distance should the object from the lens be placed so as to form an image at 10 centimeter from the lens? So image distance is given as 10 centimeter, and here object and image will be on the same side of the lens. Even v also you must take it with the negative sign only, and u must be calculated and m must be calculated. So use lens formula, 1 by u minus 1 by u is equal to 1 by f. 1 by f. Right? Now this implies 1 by u will be equal to 1 by v minus 1 by, okay, 1 by u will be equal to 1 by v must be taken with negative sign, 1 by minus 10 minus 1 by minus 15, right? So this will be equal to minus 1 by 10 plus 1 by 15. So if you take the LCM, how much it will be? 30. 10 3 times minus 3, right? Plus 2. Minus 3 plus 2 will be equal to minus 1. So 1 by u will be equal to minus 1 by 30. Therefore, u will be equal to minus 30 centimeter. This will be the object distance in this case. Now, magnification. M is equal to V by U is equal to, what is V here? V is 10, right? U is 30, that will be equal to 0.33. This will be the magnification. Remember, magnification is just a number because it is the ratio of similar quantities. This will be the magnification. So, we know that in case of concave lens, we get highly diminished images. Is it not? When compared to the object, the magnifier, the image will be almost 1/3 of the object only. The image will be 1/3 of the object. Okay. These two problems you have to pop it out. So next problem, a converging lens has a focal length 40 cm, calculate its power. So we have studied about the concept of power also. Power is nothing but what? It is a measure of the deviation of the light when it undergoes refraction through a lens. So how it is deviated, whether the deviation is towards the center of the lens or away from the center of the lens, depending on that we will decide the power of the lens. So here he has given a converging lens has a focal length 40 cm. Converging lens means convex lens it is. So focal length of convex lens is the positive. So it must be taken with positive sign. We have to calculate the power. We know that P is equal to 1 by F in meter. But here the focal length is given in centimeter. Therefore, P will be equal to 1 by 40 centimeter. 1 by 40 centimeter. That will be equal to 100 by 40, right? 100 by 40 if you take it in meters. So, how much we will get? 10 by 4 will be equal to 2.5. P is equal to 2.5 and it is a convex lens or a converging lens, and we know that the power of the converging lens is positive. For convex lens it is positive, and what are the units? It is diagonal. P is equal to plus 2.5 diagonals. Okay. So this will be the solution. One more similar problem I have. The focal length of the concave lens is 10 cm. Calculate its power. So focal length of the concave lens is 10 cm. We know that for concave lens we have to take with the negative sign. Power must be calculated. P is equal to, again 1 by F in meters it is. If you take it in centimeter, it will be equal to 100 by 10. Is it not? And for concave lens, the focal length is negative. So it will be equal to how much? Minus 10. Therefore, P is equal to minus 10. What will be the units? Diameter. This will be the solution. So very simple problems we will have on power of a lens. Okay children, we shall now discuss some of the applications of lenses. So, lenses are used in optical instruments such as telescope, camera, slide projector, etc. In all these optical instruments, we are using a convex lens which gives real and inverted images. Then even in our eye also, there is a convex lens through which light passes through and an image will be formed on the retina. Then, to rectify defects of the eye, we are using lenses. Suppose if a person is suffering from short sight or myopia, then that defect can be rectified by using a concave lens. And if the person is having hypermetropia or long sight, then the defect can be rectified by using a convex lens. Okay. Next, it is used as a magnifying glass. We are using convex lens as a magnifying glass. Then we are using convex lens especially in case of spectroscopes. So the collimator of a spectroscope is made of a plane of convex lens which renders light rays parallel. Okay. So in spectroscope, to obtain the spectrum, we are using a convex lens. Next, it is also used as an objective lens of a Galilean telescope. So in case of Galilean telescope, we are using concave lens. This concave lens will give us the final erect image of the object. So in case of Galilean telescope, we are using a concave lens as an objective lens. These are some of the applications of lenses.